Hey everyone, it's Mr. Canfield. We're going to be finishing up implicit derivatives today. So let's look at example 11 from the notes. So I'm on page 55, example 11. It says find the equation of the tangent line to the given curve at the given point. Well, here's our curve. Root x plus root y minus 1 is equal to y. And we want the tangent line at 9, 4. So just a reminder, tangent line, I'm going to use point slope form where I can use y minus y1 is equal to m times x minus x1. And well, I already know the y and the x, so I can say y minus, I almost wrote 9, be careful, that's the x. Y minus 4 is equal to m times x minus 9. All I need is m, and I'm going to get m by finding y prime. And then I plug in 9 and 4, not 9 plus 4, maybe I should use the and symbol. Plug in 9 and 4. Okay, so this derivative, well, let's see. Derivative of root x. If I have to re-explain to you the derivative of root x, it means you don't know it well enough, and I don't mean that in a mean way. I just want to say what I'm about to tell you, if this is news, you need more practice. Do more practice. Spend more time practicing. Like, do the problems differently. Remember, root x is x to the 1/2. So we bring the 1/2 out front, x, and then we subtract 1 from that, we get negative 1/2. The negative 1/2 goes to the bottom, so it's 1 over 2 x to the 1/2, which I can rewrite as 1 over 2 root x. I don't know if that was very helpful. That might have been too quick. Anyway, 1 over 2 root x. Remember, a dx pops out, but who cares? Then we have this one, 1 over 2 root y, and I can multiply that by a y prime. Minus 1, the 1 goes away, turns into a 0. And over here we have a y prime. Okay. So we could do stuff to get y prime by itself, or we could plug in the 9, 4. It is a matter of personal preference at this point. It's not a matter of correctness. I think a pure math teacher would really want to make sure that they go through and solve this completely for y prime before we do anything else. It's a little bit extra for this one. I'm just gonna plug in the 9 and the 4 now. If you're not sure how you would solve that completely for y prime by itself, let me know so I can help you with that. So 2 root 9, oh wait, root 9 is 3, right? So this is 2 times 3, so this is really 1 over 6. And this is, root 4 is 2, so it's 2 times 2, 1 over 4. So little trick here to clear out fractions. Multiply both sides of the equation by a convenient number. I'm going to multiply both sides by a number that 6 and 4 both go into, which is 12. If I do that, well, over here I get 12 times 1/6, which is 12/6, which is 2. And this one I get 12/4, which is 3. And then over here we have 12y prime. Now to solve this, I'll just subtract the y prime from both sides, get 9 y prime, so y prime is 2 over 9. And you're done. So we can find tangent lines like we used to. They're going to need to give us an x and a y, and if they don't, there's a potential that there's going to be more than one x and more than one y. We're going to have multiple points. Hazelnut. Am I slurping loud enough for you? I'm so sorry. I was in the middle of drinking my coffee and I realized, oh, this is probably really, really awful to listen to. Almost as awful as the mathematics. JK, JK. Okay. So this one we want the tangent line at 1, 1 given to us in the problem. If they don't give it to us again, there's not a whole lot you can do. So let's see, y minus our y value, gonna find our m value, and then x minus our x value. Okay, I like to just put the answer there, remind myself what my goal is. Okay, so derivative time. On the left, we got a squared on the outside of everything, so I'll bring the squared out front, bring it down to a 1, leave the inside alone, and then multiply by the derivative of the inside, which is 2x plus 2y, y prime. It's hiding a little bit. Let me just throw that in another color just so I remember that later. Oh, sorry for all the sniffles. I've got pretty nasty allergies this time of year. All right, so here I'm going to do the derivative. So we'll take the derivative of the 4x squared first and get 8x. Leave the y alone. Leave the y alone, sorry. Then leave the 4x squared alone, to the derivative of the y. So it looks like I've got a y prime here and here. So again, we could go through and completely solve this for y prime. And when I say that, I mean, I'm pretty sure we can. It's gonna be, yeah, we definitely can. It's gonna be a little bit of a slog to get through. Instead, we know x and y are both 1. Well, why don't we just plug them in? 1 squared plus 1 squared, 2 times 1 plus 2 times 1 times y prime. I'll keep using red for y prime. 8 times 1 times 1, 4 times 1 times y prime. Already it's looking a little bit better. And this was, you know, this is a slow version of this. I'm sure a bunch of you can do this quicker than this. So this is 2 times 2, this is 4 times 2 plus 2y prime is equal to 8 plus 4y prime. So then what we got? 8. Oh, are you? No. Oh. No. Really? Do you see why I'm annoyed? Subtract the 8s from both sides. They cancel. I mean, it's totally possible that I made a silly mistake somewhere, because I'm prone to that. But I get 0 is equal to negative 4 y prime. Don't know why I'm solving it that way. Don't know why I didn't subtract the 4 from both sides, but y prime is equal to 0. So y is equal to 1 winds up being our line, right? Because the 0 clears all that out. 0 times all that goes away. Add the 1 to both sides. So I am just going to double check really quick. I am not super confident about that answer. It feels like I maybe made something silly. So I'm just going to double check, see if Stu got the same thing. Notice my language though. I'm seeing if Stu got the same thing, not if me and Stu are both right. So Stu got the same thing as me, so it's most likely we're right. Just because somebody agrees with you doesn't mean that you're correct. All right, now we're going to find points of horizontal and vertical tangency for number 13. And I believe this is our this is our last example. Okay, so we want horizontal and vertical tangency. Number 13. All right, it says 25x squared plus 16y squared plus 200 x minus 160y plus 400. So there's a special topic you can do in pre-calc called conics, and it's examining all these different shapes that you get from cutting cones in different directions. And this actually is the equation of something called an ellipse, which instead of being a circle, you know, if you think about having a circle and if you look at the shape that circle makes at this angle here, that oval, that's an ellipse. And so if you were to cut a cone at a weird angle like that, you get a weird oval like that, we call it an ellipse. I could have just said, picture an oval. That's called an ellipse. High quality education. All right, so I'm gonna take the derivative. We'll talk about what to do with horizontal and vertical tangent. All right, so we get 50x, x prime, but x prime is 1, so we don't care, plus 32y, y prime, plus 2 hundo. All right, I'm gonna stop saying that. Minus 160 y prime plus the 400 turns to 0 equals 0. All right, so pretty straightforward. I'll subtract the 50x and the 200 from both sides, and so say negative 50x minus 200. I like to jump this next step. I don't know if I said that in the last video, but I know I'm going to factor the y prime out of both of those and divide by the 32y and the minus 160. I won't do that for the sake of this video. For instructional purposes, I want to be as helpful as possible. So now when I divide both sides by that, we get y prime is equal to negative 50x minus 200 over 32y minus 160. Okay, so a horizontal tangent think about it. Horizontal tangent. Horizontal goes this way. What's the slope of a line that goes that way? 0. This means y prime is equal to 0. How do I get a fraction to be 0? Let's think about this. What's 0 over 0? No, right? That's undefined. With limits, that means that there's stuff we got to do. It's an icky situation. What about 0 over a number? If you're not sure, go to your calculator, literally, like type these in if you're not like 100% convinced about them. Take 0, divide it into any number of parts, it's still 0. Take any number and divide it into 0 parts, and you no longer have a number. But this undefined, wow, this undefined up here and this undefined down here, they're very different. When we had the 0 over 0 in limit world, that was a problem. It was weird. It meant that we had to do other stuff. In limit world with this, it meant it was some form of infinity. So when we're dealing with numbers, we essentially treat this like infinity. And for all intents and purposes for this course, this is infinity. So, or negative infinity, depending on what the number is. But if you think about an infinite slope, sorry. An infinite slope goes like wah, wah, straight up and down. Slope of 0 goes flat. So if you notice, make the top 0, you get a flat slope. Make the bottom 0, you get a vertical slope. That's all you need. So if I make the top 0, solve it. I'll add a 200 to both sides. Divide by 50, well, negative 50, what, negative 4? All right, cool, so we got x is equal to negative 4. Now when x is negative 4, what's y? I don't know. We'll go back to the original then and plug it in and find out. So 25 times negative 4 squared plus 16y squared plus 200 is negative 4 minus 160y plus 400 equals 0. All right, we just got to go do some algebra here. So negative 4 squared is 16. 25 times 16. That's 16 quarters, right? Like, so 25 cents, 16 times, and every 4 quarters gets us $1. So what is that, $4? So 400. Then this is minus 800. minus 160y plus 400. Oh, interesting. So the negative 800 and the 400s cancel each other out, right? So we'll get 16y squared, 16y squared, that's what that number is called. 160y is equal to 0. Okay, so we can factor and solve this. So I'll factor out a 16 and a y and be left with y minus 10. So let's say set this equal to 0, I get y is equal to 0. This one set equal to 0. Add the 10 to both sides, get y is equal to 10. So we had the x value negative 4. We got two different y values. And if you go back and you think about that ellipse, you go think about what you've done. You know, an ellipse is an oval, right? An ellipse is going to have two places where the tangent line is horizontal. And, you know, not to give too much away, it's going to have two places where the tangent line is vertical as well. So if you notice, the x value was the same for that and that, which, you know, makes sense considering what an ellipse is. So on this one, we can expect that the y values are going to be similar. So let's see what happens. 32y minus 160. So we'll set that equal to 0. And oh, yep, sure enough. So we'll find a point of vertical tangency. Vertang. All right, so we'll set 32y minus 160 equal to 0. Again, if you're not sure why I'm doing this, go back a little bit. I talk about fractions. That's why we're setting this equal to 0. So I'll add the 160 to both sides. Divide by 32. 5? Yeah. So, because 5 times 30 is 150, and then 5 times 2 is 10. So 150 plus 10 is 160. Okay, so y equals 5. So now I go back to my original equation, 25x squared plus 16 times 5 squared plus 200x minus 160 times 5 plus 400 is equal to 0. Okay, so 25 and 16. Oh, that's interesting. So, you know, earlier we did 25 and 16. And now we're doing 16 and 25. So I know that this is the same number that it was before. $4, 400, right? Plus 200x. So what is this? 500 plus another 30. Nope. Not another 30. Another 300, because 60. So 800. Okay, we're getting lucky, and it was not lucky, but because this was definitely engineered for us. But 400 minus 800 plus 400, those all cancel. 25x squared plus 200x is equal to 0. I'll factor a 25 and an x out. We'll get x plus, okay. What is that, 8? 200 divided by 25. So there's 8 quarters and $2. Now we get x is equal to 0, and then we get x plus 8 is equal to 0. Subtract the 8 from both sides, get x is equal to negative 8. So we get vertical tangents when y is 5, and when x is 0, or negative 8. So there we go. If you want to see what this graph looks like, I'll show it off real quick. Right there. That's what our ellipse looks like. And you can see the vertical tangents and the horizontal tangents would occur at the points that we found. So Whoops. There we go. Hey, I hope this video was helpful. Yeah. Bye.